Good morning, friends. I hope you are following the thermodynamic lectures. In the last class, what we discussed means adiabatic process. What is the relation between the PV and VT and TP relations in the adiabatic process we discussed. Today, our goal is to learn about the PV graphs and VT graphs in TP graphs in adiabatic process. Let me start with the PV graph first. So, I am taking the PV graph. So, to draw any graph, we need to know what is the relation in that process. So, we are in the adiabatic process. What is the relation between the PV relation in the adiabatic process? That is equal to PV power gamma is equal to some constant we are getting. That means then P is equal to some constant into divided by V power gamma we will get. Then P is inversely proportional to V power gamma. This is the relation we are getting. So, you know the gamma is equal to the adiabatic constant, that is equal to Cp by Cv. This value is always greater than 1. That means it is a positive value. Then the P is inversely proportional to V power some a positive value, that is equal to, I am taking that value is equal to some A, depending upon that one, some A we are getting. Now let's assume here is the gamma also, no worry about that one. Now please understand, if V is increasing, then pressure will decreases. They are inversely with help of some power. And also if V is decreasing, then P will be increases. Then how the graph shape will look like? So the graph shape will look like, at high pressure the volume will be low, at low pressure volume will be high. So the relation between this one, they are decreasing. It is decreasing from high pressure to low pressure. That is the PV graph shape. Now here is the P and V. This is the graph for the PV graph. Now let me go to the VT graph. So in the VT graph, to draw any graph, we need to take the relation. In the adiabatic process, what is the T and V relation? So T V power gamma minus 1 is equal to some constant. We are getting some constant. Now I am sending this V value this side, the power I am sending to that side, that is equal to T 1 power gamma minus 1 is equal to V, that is equal to some constant. Then V is equal to some constant divided by T power 1 by gamma minus 1 we will get. So as we know, gamma is the positive value, that is equal to Cp by Cv, that is always positive value greater than 1 and also positive value. This positive value I am substituting this in this equation, the total value 1 divided by gamma minus 1 will get the positive value, that positive value I am taking A. Then V is equal to some constant divided by T power A, that is also positive value. A is equal to always greater than 1 and positive value. Then we can write it, the V is inversely proportional to T power A. Then what we understand here, if T decreases, V will be increases. If T increases, then P will be decreases. Then what is the graph shape? In the previous shape only we will get, depending upon A, the slope will be decided. So then the previous shape only, this is the graph is decreasing. At a high V value, T will be low. At a low P value, the T will be high. So this is the relation, where this is the graph shape in this VT graph. Now let me go to the PT graph. Again, to draw a graph, definitely we need a relation between the P and T variables. What is the relation in P and T variable? In the adiabatic process, P 1 minus gamma into T power gamma is equal to some constant. Then I am sending to this P value to that side, the power value to other side, then P is equal to P into T power gamma divided by 1 minus gamma, that is equal to some constant. Then P is equal to some constant divided by T power gamma divided by 1 minus gamma. Once again we are recalling gamma is a greater than 1 value, then here is the 1 is there greater than 1 value, this is the negative, this is the positive, whole term will get a negative term. That negative term I am assuming negative a. Then this formula can be written as P is equal to some constant divided by t power minus a. Now if we bring the denominator to numerator, it will become a positive. Then P is equal to t power positive a into some constant. Then we will write the P is directly proportional to t power a. Here a is a positive value, they depends upon the gamma value, so is a positive value. To draw the graph we are taking. Then if P increases, t will also increases. If P decreases, the t will also decreases. If P increases, P decreases, t also will be decreases. Then how the graph will look like? They are not directly proportional, they are not in the linear proportional, they are having the some power is there. That's why the graph shape will look like this. Depending upon the shape of the graph will be, it is a curved graph because of the power of a is decided this curve. So the shape of the graph like this. There is the P here and also T here. Now we need to go for the what is the slope of the graph in the PV relation. That is also very important one. So the slope of PV graph in an adiabatic process. That is one of the important question. We need to know this one. So let me start with the PV graph once again. Let me draw this one. So in the PV graph, how it look like? This the PV graph shape will be like this. Then the goal is to find out the slope. This is the slope theta. So here is the pressure is there. Here is the volume is there. Then the slope is equal to dp by dv. That is our goal to find out this one. So to find out this one, it is the tangent which is drawn at this point. So we have the relation PV power gamma is equal to some constant. P and is the variable, V also is a variable. Now we need to do the partial differentiation of this equation. Now for forming the partial differentiation, keeping the P is the constant, differentiating the V, that is equal to gamma into V power gamma minus 1 into dV, plus V is I am keeping the constant, that V power gamma into dP, that is equal to constant differentiation will get that 0. Our goal is to find out the dP by dV value. Just I am keeping VV power gamma dP is equal to sending the remaining term all to other side, P into gamma into V power gamma minus 1 into dV. Send dV value this side, remaining term I am sending to other side, then what we will get, that is equal to dP by dV is equal to negative term of P into V gamma is there, gamma into V power gamma minus 1 is there. This term I am written, the other side we are getting V power gamma. Then dP by dV is equal to negative term of gamma. Here VV power gamma, this VP power gamma, this VP power gamma cancel. Negative term of V power minus 1 we will get, that I am sending to denominator, that is equal to P by V. Once again I am writing the slope is equal to slope of adiabatic process. Is equal to dP by dt. dP by dV is equal to negative of P by V. We are recalling this P by V. What is the P by V is equal to? It is nothing but slope of isothermal process. We know that we have the formula. We know that what is that? We know that P by negative of P by V is equal to slope in adiabatic isothermal process. Then slope in adiabatic process is equal to gamma times of slope in adiabatic isothermal process, that is equal to slope of adiabatic process adiabatic process is equal to gamma times of slope of isothermal process. So that means if you go to the what is the ratio between the slope of adiabatic process and isothermal process is equal to, then slope of adiabatic process divided by slope of isothermal process is equal to isothermal process is equal to, it is the gamma. So gamma is what is the value? Gamma is equal to Cp by Cv. Cp by Cv is equal to always greater than 1. This value is always greater than 1. This value is always greater than 1 because of gamma is always greater than 1. So this is the value we are getting. So this is the relation about the PV graph and VT, VT graph and TP graph, and also relation between the slope of isothermal process, slope of adiabatic process. I hope you are if you are enjoying this lecture, I am requesting you please share this video to your friends and subscribe the channel. Thank you for your support.